What causes the violent explosions that we see on the Sun? Why are there sunspots on its surface? How do its magnetic fields behave? The Sun may be close to us, but it is constantly raising new questions for the world's astronomers to answer. Solving the riddles of this star, which was first observed through a telescope in the time of Galileo, opens the way for our understanding of other stars. The Sun is a huge fundamental physics laboratory for improving our knowledge of the universe. The Sun is the star at the centre of our solar system and the largest source of energy within it. It is the only star in the whole of the universe that we can observe from the Earth in detail. To help us understand the processes at work in the Sun, the largest ever European solar physics research facility is taking shape, the European Solar Telescope, or EST. Research institutions from 15 different European Union countries have joined forces to drive this project forward by setting up the European Solar Telescope Association. This new telescope will have a 4-metre primary mirror and the most advanced technology available today, giving astronomers their most powerful tool ever for observing the Sun.
EST will be at the forefront of solar physics because with its 4-meter diameter will enable us to see very small details as we have never seen on the solar surface. And we will see how the magnetic field emerges to the surface, how it interacts with the plasma, how this magnetic energy is transformed into thermal energy, and how finally all this energy is dissipated in the form of flares or ejections of mass to the interplanetary medium.
The conceptual design study for the telescope was coordinated by the Astrophysics Institute of the Canary Islands, or IAC, with funding from the EU's 7th Research and Technological Development Framework Programme. In all, 30 different European institutions worked on it, 15 of them from the private sector.
EST is really needed as a European project because it is a field where many countries all have their own disciplines. To build such a big instrument, you need a lot of discipline together, and one institute which is dealing with solar physics never can do that because we need so much different expertise.
EST is necessary as a European project, first because of its size. We're speaking of a telescope which is 4 times larger than this one. Of course, Europe has a large experience in building solar telescopes, but not any single country can take the responsibility of funding and building such a thing.
It requires a significant economical effort to produce a telescope of this size, and I think only as a combined European effort this will be feasible, but the European community is strong enough to actually shoulder this kind of a project.
EST will be built at one of the IAC's international observatories in the Canary Islands. The Teide Observatory on the island of Tenerife, or the Roque de los Muchachos Observatory on the island of La Palma. They are both among the world's best locations for solar observation.
Presently, there are a number of telescopes here in the observatories of the Canary Islands. There is the Dutch Open Telescope, the French Themis, the Swedish Solar Tower, and the German VTT, and some of these telescopes are more than 15 or 20 years old.
Present infrastructures can help to make to achieve the EST in many ways. We can, at a smaller scale, already now test the technologies which will be needed for the European Solar Telescope. In particular, test special instrumental concepts, test again adaptive optics, and in particular test all the data analysis and management techniques that will be absolutely necessary for the EST.
The Canary Islands are an astronomy reserve, one of the few places on the planet where the quality of the sky is outstanding for modern astronomy. This is equally true at night, as the recent opening of the Gran Telescopio Canarias, the world's largest optical infrared telescope, has shown. As with GTC, building and operating EST over a lifespan of 30 plus years will have a huge impact on science, technology, culture, and society as a whole. It will also provide a major stimulus for economic development.
Many technologies, of course in the primary, with the polishing, new way of polishing, the new technologies used to support and to work in real time with the segments, a very powerful secondary mirror and of course in the instruments. Due to the GTC, this technology has been developed in Europe. My advice to the team that is developing the European Solar Telescope is that it's possible. And for the authorities that this is an opportunity.
So what makes this telescope so different from previous ones? EST will be able to look at several different layers of the Sun's atmosphere at once, in unprecedented detail. In other words, it will observe the Sun's smallest features in 3 dimensions. EST will show us events on the surface of the Sun and the ways in which they propagate to the layers above, where they generate flares and other phenomena.
Solar flares are sudden releases of magnetic energy which are accompanied by acceleration of particles in the solar atmosphere. And these accelerated particles may form a so-called coronal mass ejection, a cloud of particles that escapes from the solar corona, from the suns, and flies through the interplanetary space and may collide with our planet.
The Sun's atmosphere is characterized by the presence of powerful magnetic fields. They are the cause of the enormous sunspots on its surface.
Without magnetic field, the Sun would be a very boring star. There would be no sunspots, no flares, no coronal structures, no prominences, nothing.
And the magnetic field is really the crucial ingredient in the Sun. The magnetic field is able to store energy. It's pushed around by motions in the solar atmosphere, and then this energy is stored in the magnetic field and then suddenly released in terms of big explosions that we call flares, or in ejection of plasma and magnetic field in the form of coronal mass ejections.
This suddenly released material sometimes heads towards the Earth and can damage satellites in orbit and pose a threat to astronauts. It can also wreak havoc with power stations on Earth. Solar storms like these also give rise to natural phenomena like the aurora borealis. Until now, scientists have been unable to look at these magnetic phenomena in detail. EST will reveal them to us and help us to understand how they're created by the Sun.
The European Solar Telescope is a 4-meter class telescope, so it's much larger in diameter than any existing telescope. And the large diameter gives us 2 advantages. One is that we can see features that are much smaller, more detailed than we have ever been able to do before. The other advantage with the large diameter is that we get more light. And it may seem strange, but in solar physics we're actually light starved. We don't have enough light to do what we want to do. And that is because we split the light into color, into polarization, to extract all the information.
EST will use sophisticated instruments for this ambitious mission. The instruments will produce such a large amount of data that processing it quickly enough will be a challenge in itself. The project must also overcome technological challenges if it is to achieve its scientific goals. Challenges like multi-conjugate adaptive optics systems and thermal control. These systems will be used for real-time correction of image degradation caused by disturbances in the atmosphere and to reduce the risk of the telescope overheating when exposed to the sun for long periods during observations. Technological challenges like these are a great opportunity for companies working in the sector to innovate.
Science is one of the main drivers for high technology industry. So a very innovative project like EST, that is a 4-meter new class solar telescope, will open important perspective for European high technology industries, because a lot of improvement in the thermal control, new materials, new optical materials will be necessary.
The European Solar Telescope has a very innovative conceptual design that will require the special technological developments in the fields of optics, instrumentation or mechanisms that for sure will imply the involvement of the industry, private industry, in the early phases of the project.
This is a compelling reason for EST to be on the list of large research infrastructure projects currently being considered for funding.
Europe has paramount importance in, for instance, deciding that this infrastructure will become a strategic research infrastructure of the future.
EST will shore up the European Union's position at the forefront of science, solar physics and technological development.
In case of EST is not built, we will not have the capacity to attract in this field of research young persons, students, which are fundamental for the future of this project.
If the EST will not be built, I believe that we will have a kind of stop in our research, and so we all think that it is really necessary to go ahead with this project.
Now that the conceptual design study has been successfully completed by the partner institutions, it is essential that the countries involved maintain their backing for the forthcoming phases of the EST project.
At the moment, it would be necessary that the National Funding Agency start to think how to help us to realize this project. Now it's time to get all these countries involved, to get this financial help.
If the scientific community, research centres, funding agencies and private enterprise continue to work together, the European Solar Telescope could see first light at the beginning of the next decade. It would be a turning point for solar physics, a window into the workings of the star that life on Earth depends on. The countdown starts now.